This week, we're going to see how to resolve some of these weird wind directions and speeds observed in the winds and temperatures aloft forecast. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. This week we're going to keep looking at the winds and temperatures aloft forecast from the Aviation Weather Center and see how we can decode a few more things that are packed into there. Last week we got our decoder working and we thought we were very happy with it, but as you start looking at the data a little bit, we see a bunch of 990 wind directions that don't really make any sense. Or maybe we see something even stranger, like 510, 520. We're pretty used to seeing 999 as a missing data value, so maybe you can start leaning towards that, but that actually isn't what it is. So let's go back up to our decoder, and let's do a couple of modifications to get this reading a little bit more accurately. All right, so the first thing that we're going to deal with, after we've checked if we're longer than 4 digits, and have decided that that means we have a temperature and decoded that temperature, is we're going to check for light and variable winds. Light and variable winds are defined as winds less than 5 knots. And what they do is they encode them as 9900. So if our data group, the first 4 characters, is equal to 9900, we know that the wind direction is none, it's undefined, and the wind speed, we could encode that however we want. I'm just going to encode it as 0, saying that this is light and variable. It doesn't really mean anything. You could code it as 2.5 knots if you wanted, since that's halfway between 0 and 5 knots. But I've chosen to encode it as 0. So let's go ahead and run this and see what it does to our output here. So we were looking at TYS. All right, so we see 0 wind speeds and no wind direction instead of 990 on the wind direction. So this makes a lot more sense. We've now decoded the light and variable code. But what about down here where we see 510 and 520? Well, this is where it gets a little interesting. If the wind is over 99 knots, it can't be encoded in those 2 digits. So they add 50, which is equivalent to 500 degrees, remember, because these are in tens of degrees, to the wind direction, and subtract 100 from the wind speed. So we need to undo that. So after we've checked if they're light and variable, we're going to check for winds over 99 knots. If our wind direction is not none, and our wind speed is not none, and our wind direction is greater than 360, we want to do this decoding. I'm going to go ahead and put parentheses here just to help my logical grouping. And we have to do this comparison because you will get a failure of a none compared to an integer. All right, so if the wind direction is greater than 360, we know that it must be because we've got winds over 99. So the wind direction, we're going to subtract 500, and the wind speed, we're going to add 100. So now let's decode again. And we see that these are now winds out of 10 and 20 degrees instead of 510 and 520. And our wind speeds are now 170 and 199. So we've added yet another one of these special cases to our code. But there's one more that doesn't really require any coding unless you want to do something different with it. I chose to leave it like this, and that is the wind speed of 199. Any wind over 200 knots is encoded as 199. Since we don't have a way to represent 200 or greater, but we could set that to 200, put some logic in, but I chose just to leave it as 199. All right, so now we have a function that works, does most of what we want, But it's pretty long, and it does a lot of things. Now, granted, it would still fit on a printed page. So it may not be too big of a deal. But I want to split this up a little bit, make it a little easier to understand. A logical block would be parsing data groups. So we'll go ahead and copy that. Scroll down here, and I'm going to capture that as results, just so I don't have to scroll so far. I'm going to define a function, parse data groups, or parse data group actually. I want to parse one. If we can do one, then we can call this function in a loop and do many. And we know to do that I'm going to need the data group and the level that it's at, because if it's above 24,000 feet, we have to know to multiply our temperatures by -1. So this parses a single data group at a given level. And we can go ahead and paste. Get our indentation right. And now we can start cleaning things up. So DG is probably not the best name. Also, this was looping over many data groups. We don't need to loop over data groups. We're going to just do one. So I can remove that, unindent. I'm doing that with Shift Tab. I'm going to use the name data group instead of DG. Again, it's just more readable to somebody that doesn't know the code. So you could find a replace. The reason I'm not is as I'm going through and replacing this, I'm reminding myself of the structure of the code. It's been a week since we've written this code. We don't remember necessarily exactly how it works, so it's good to remind ourselves by going through and reading it. Okay, so we are first off going to update our comments, clean any extra characters. This first case is there's nothing to parse. Instead of setting wind speed, wind direction, and temperature, I'm going to just return none, none, and none for speed, direction, and temperature. The next thing we're going to need to do is break out text for winds and temperature. The wind text is going to be the data group, the first 4 characters. And then if the length of our data group is greater than 4, temperature text is going to be data group from 4 to the end, else temperature text is none. So I'm breaking out the text strings before I do anything else. This just makes my life a little easier and makes the code more readable. First, we're going to parse the temperature. Let's go down to our temperature parsing logic right here. We have this if len data group. We're going to grab that, put it here, get our indentation right. But in this case, it's if temperature text. We've already done this parsing. So if temperature text is not none, which is implied here, then we're going to say temperature is int of temperature text. If the level is greater than 24,000, temperature times equal -1. So that's all good. Next, we're going to parse winds. We know how to do that right here. We don't need the temperature. Wind direction, integer, wind text, first 2 characters times 10, wind speed, wind text 2 to 4. All right. Now we're on to this check for light and variable winds. I'm going to unindent. And in this case, we're going to say if, because we're not checking the string anymore, we've already parsed wind direction and wind speed out. If wind direction is equal to 990 and wind speed, you probably wouldn't have to check both of these conditions. I just think it's a little more thorough to do so, is equal to 0. Then we're going to return what? We're going to return a 0 wind speed, because that's what we chose to do, a none wind direction, and the temperature, which could be a real value or it could be none. And then finally, we're going to check for winds over 99 knots. In this case, if the wind direction or wind speed is none, we will have already returned. So we can simplify this to just say if winds, the wind direction is greater than 360, wind direction minus equals 500, wind speed plus equals 100. And then finally we return wind speed, wind direction, and temperature. So we took the same functionality, but we've broken it down into a more readable, a little bit better variable named function, something that someone else could come along and potentially understand. The next thing that would make sense to me is to parse a station, which is a whole line. It's a series of data groups. So if we look back up here, how do we do that? Well, here's for L in lines, so we're looping over lines. We're extracting data groups here, and we're parsing data groups. So let's grab that text. We're going to create our new function, parse station. It's going to take a line of text and the levels that is at, because the levels are on the first line of the file. Parses all data groups in a station line for winds and temps aloft. We paste in, unindent. All right, so we're getting our station name. We called it line instead of L. That's an important change. We are getting our data groups, so we need to get our indexes here and put them in this function, group all of that together. All right, there's another L. That's going to be a line now. Line. It's time to parse our data groups. So I'm going to again keep that sort of same loop structure that I had, which was for level, data group, and I am going to use DG here because it's going to be obvious since data groups is right after it. In zip, levels, data groups, wind speed, wind direction, temperature is parse data group level. So now all that logic on how to parse that data group is abstracted away into this one function call. Much more readable. Wind speeds dot append, wind speed, wind directions dot append, wind direction, temps dot append, temperature. And we're going to return the station, the wind speeds, the wind directions, and the temperatures. All right, so now we've got one function that handles a line. So we've got a function that handles a chunk of a line, a function that handles a whole line. Now we need a function that handles a whole file. Some folks like developing bottom up like this. Some develop from the top down, whichever way you're more comfortable. In this case, I liked working on the smallest piece and building to the largest. So finally we get to the largest piece. Better parse forecast. I'm just calling it better because it's a better formatted version of it. So we go back up to our initial function. And we know we're going to need this logic. The doc string is it parses a winds and temperature aloft file. Now we do have some repeated information here. Maybe this is saying this should be written into a class. Maybe that's an exercise we'll do if there's interest in seeing how we would take an object-oriented approach to this. But for now, let's just stick with these functions. So we've got our lines as f.readLines. We read the levels from the first line. None of that logic changes. Then we need to parse each station. So for line and lines, the station, wind speeds, wind directions, temps, we're going to call our parse station function with line and levels. Sites, station is going to be equal to, and we could probably pull this from earlier. Save ourselves a little bit of typing. So level is going to be levels. In fact, I'm going to make that singular this time. Wind speed, wind speeds, wind direction, wind directions, temperature, temps. That all looks good. And then after we've parsed every station, we're going to return sites. So now we call our better parse forecast function on winds.text. And we see where we need to start troubleshooting because we know it's probably not all going to work the first time. So we see that we've referenced temperature before assignment. So we start reading up our docstring here, our error, and see where this is coming from. So in better parse forecast, we call parse station. In station, we call parse data group. And we see that it's right after our wind speed. So we're getting down to here, and it says we have never assigned a temperature. So let's see where we could have a problem. So as you may have spotted when we were doing this, we set temperature text to be none, but down here when we're parsing the temperature, we say if temperature text and we parse it, we never provide an else condition. So if we don't have temperature text, we need to make sure to set the temperature variable to none as well. And now we see we're getting one station back. And it's the first station. This is where we start running into some of the hazards of doing this copy and pasting and in the notebook having stale things lying around. We've got some variables that would still work, but probably aren't actually current. They're from previous iterations. So if we start looking carefully at our better parse forecast, because we know that the parse data group and parse station are probably working, let's start looking. Okay, L is lines.pop. Okay, for line in lines, we're calling with line. We're looking for anything that looks outdated. One thing that we could do is put a print statement in, look at each line, and we say, yeah, we are calling it with different lines. Aha, here we are. We called station stn on return, and in this copy-paste error, we use the full word station. All right, so now we're getting everything back as we would expect. We might want to go look at some of those special cases, like the 199 and 170 knot winds, make sure those work. Go back up to TYS, make sure that the speed and direction are working for light and variable. And now it looks like our parser is working. So we've taken one pretty complex function, broken it up into three simpler functions that are easier to maintain, easier to use individually, and a lot more readable because you only have to understand the piece that you're having an issue with. I hope that you found this useful, and I'll see you on next week's MetPy Monday.